Hi math students, it's Miss Carol, and we are still on Unit 3 project, Lesson 14, and we have 4 questions that apply to scientific notation that are kind of fun that we're going to dive into today. Here's the background. From pollen counts to number of visitors, from landscape invoices to water microbe statistics, many of the numbers that the park administrators deal with are best written in scientific notation. Apply scientific notation to solve problems in the frog-infested local park. Okay. First question. By the time park officials finished introducing frogs into the parks, the frogs had multiplied to a staggering population of 2.56 times 10 to the 6th power. What is that number written in standard notation? Okay, so they gave it to us in scientific notation, and they want us to write it in standard notation, all right? So what we need to do is we need to actually multiply that 2.56 by 10 to the 6th power to figure out what it is in standard notation. And the easy way to do that is to write that 2.56, okay? And then we take note of this exponent, and we're going to move that decimal place 6 places to the right, all right? If this exponent is a positive, we're moving the exponent, we're moving the decimal to the right. If it were a negative exponent, we would be moving it to the left because we'd be dealing with very small numbers. Okay, so we're moving it 6 places. 1, 2. Okay, now we're at a place where we have to add zeros. 3, 4, 5, 6. So I have to add zeros in every single one of those. Okay, so this then becomes 2,560,000 frogs. 2,560,000 frogs. That is a lot of frogs. I think they might have more frogs than they originally had insects. Maybe not quite, but close. Okay, so 2,560,000. Let me get my little thing out of the way here. And so that's all you would write there. That's written in standard notation. All right, now we're going to go the other way. To counteract the frog population spike, the Parks Department has decided to introduce a large number of predator fish into their habitat. Oh my goodness. They have purchased 12,000 fish to stock the bodies of water. It seems like maybe they shouldn't be messing with the ecosystem. It's getting out of control. So they want us to write 12,000 in scientific notation. So we're just going to work the same sort of problem backwards. All right, so let's start with 12,000. Okay, notice our decimal point is right here. And when we write in when we write in scientific notation, we can only have one number to the left of the decimal point. Okay, so the left would be our 1 there. And then we're going to start here, and we're going to count how many spaces it takes to get from having the decimal here to having the decimal here. So this is 1, 2, 3, 4. All right, that becomes our exponent. So now we have 1.2 times 10 to the 4th power. All right, I can verify this because if I started with 1.2 times 10 to the 4th and I multiplied by that 4 tens, I would get 1, 2, 3, 4, and that is the number that I started out with, okay? So essentially it's 10 to the 4th. What happens here is I'm saying 1.2 times 10, okay? That's 12, all right? 12 times 10 is 120. 120 times 10 is 1,200. Okay, 1,200 times 10 is 12,000. All right, 1, 2, 3, 4 tens. 1.2 times 10 4 times is 12,000. All right, so remember they asked, I gave you a little bit more than they were looking for here, but they asked us to write this in scientific notation, which means we say 1.2 times 10 to the 4th power. Okay? Hopefully that makes sense. We've got 2 more questions here. The snack bar at the park sells an average of 1.2 times 10 to the 5th drinks per year, and it sells an average of 4.0 times 10 to the 4th hot dogs per year. How many times more drinks than hot dogs does it sell? Okay, so I've got 1.2 times 10 to the 5th, and I've got 4.0 times 10 to the 4th, so I've definitely got some exponents to deal with here. Okay, there's a couple different ways to tackle this. I'll show you a couple that I can think of right off the top of the bat. So the first thing that I would do is say, okay, I know this is a division problem. I've got to divide 1.2 times 10 to the 5th by 4.0 times 10 to the 4th. I could hop on my calculator and do that, but I also think we can do it with just mental math. So 4 doesn't go into 1.2. But 4 does go into 12. So let's go ahead and steal a 10, all right, and move it over here. So if we move this here, then we can make that 4, all right? So now suddenly I'm going to have 12 times 10 to the 4th divided by 4 times 10 to the 4th. Oh, lucky for us, those 10 to the 4ths are going to go away, and we just have 12 over 4, which is 3. So we know that there's 3 times as many drinks sold per year as there are hot dogs sold per year. That's one way to do it, okay? Another way to do this is going to end up being very similar, but is we can simply say, all right, let's take that 1.2 times 10 to the 5th, and let's take that 4 times 10 to the 4th, and let's do a division problem. And let's first just tackle these, okay? We know that the bases are the same, so we can subtract the exponents. So we're going to say 1.2 divided by 4 times 10 to the 5 minus 4 power, or this becomes 1.2 over 4 times 5 minus 4 is 1. 10 to the 1st is just 10. Okay, so I could say 1.2 divided by 4 is 0.3, and 0.3 times 10 is 3. All right, there's definitely even more ways to solve this, but those 2 methods, hopefully one of those kind of clicks with you. Of course, you can always plug either into your calculator or Google and get the right answer there. But I guess the last way to do it that I see right off the top is, let's see, 1.2 times 10 to the 5th becomes 1,200,000. So it's 120,000 divided by 4 times 10 to the 4th is 40,000. And that is 3. So again, numerous ways to do this. It's up to you which way you choose. Okay, the snack bar at the park, again, sells an average of 1.2 times 10 to the 5th drinks per year and 4 times 10 to the 4th hot dogs per year. Explain why it's useful to record these numbers in scientific notation rather than standard notation. Okay, so hopefully you're all familiar with why scientific notation is helpful, but here's what I would say in this situation. I would say that scientific is more useful than because these are large numbers and they can be condensed using scientific notation. It is a more efficient way to communicate these values. Okay, so scientific notation is more useful than standard notation because these are large numbers and they can be condensed using scientific notation. It is a more efficient way to communicate these values. So feel free to copy this verbatim. I just want to remind you that these projects, the reason that I am doing all of them is because I really want you to be watching these videos. And the way that I'll know that you've watched these videos is if you copy these answers word for word. So it's basically like participation. And I am totally fine with that. I would not be fine with you copying anyone else's work for discussions because that's where I want your own work. That's different than participation. Hopefully you are still learning by watching these videos, and that's really my goal for this. So again, it's okay to use what I've written there. That's all I have for lesson 14. I will see you back here for lesson 15. Thank you for joining me.